Good evening. First of all, I would like to thank the organizer, all of them, for this conference and for giving me the opportunity to be here. It is really something special. I'm a physicist, and very often physics conferences are quite boring. It's not the case, this one. So I'm very glad to be here. On the other hand, however, it is quite difficult for me to talk about something which has to do with physics after such a beautiful lecture by Professor Gus. It's not easy to be clear as he has been talking of such beautiful phenomena. Well, the title of my talk is My Double, the Arrow of Time and Consciousness. I do not know if there is anything to do with consciousness, but in any case it's nice to spend these 40 minutes with you just pretending that there is something about that. You will see also why I talk of my double. Okay, let me start from an observation of a laboratory, which is called Lashley dilemma. Lashley introduced the concept of mass action in the storage and retrieval of memories in the brain. And let me read this quote by him. We are into forces. I put a reference here. Oh, there is a pointer. Okay, how it works. Okay. So, Lashley says, here is the dilemma. Nerve impulse are transmitted from cell to cell through definite intercellular connections. Yet all behavior seems to be determined by masses of excitations. Let me stop for one moment. Here we have a transition from cell to cell, which are two of them, in any possible coupling, to many cells, masses of excitations. So it makes a big difference when you go from small numbers to large numbers. This is very important in physics and in many cases, not only physics. Okay. Okay. Yet all behavior seems to be determined by masses of excitation within general fields of activity. Here there is the introduction of another word, which is a strange word, fields. What is a field? We will maybe go back to that. Without regard to particular nerve cells, what sort of nervous organization might be capable of responding to a pattern of excitation without limited specialized path of conduction? The problem is almost universal in the activity of the nervous system. I'm not a neuroscientist, but by getting along with neuroscientists, I understand that this dilemma is still there. We still do not know how it is possible that some hundreds of billions of neurons, with the addition of a glia cell and water, and all that, how out of such so many components, elementary components, could come out a stable functioning of the brain as we see at functional level. This is the point. How is that possible? On the basis of such, pointing the street to what to do, Karl Pribram introduced this, sometime we call it metaphora, a theolographic metaphora, meaning that the brain, according to Karl Pribram, operates like an hologram, namely like a coherent state in laser physics, where in each point of, let's say, of a picture is concentrated the information which you find in all the other parts of the picture. So the transition from local activity to global activity is clear. This one is Walter Freeman. I like to present him the picture, his photograph to you, because he will be 90 in this next year, and he has been working in neuroscience since his life, and he is on the path of that Lashley dilemma, trying to understand how the brain functions. So not only how a neuron works, that is crucial to know, but that is only the first step. After knowing all the possible details, we have to put together these details in a consistent frame, so to get out the functioning of the whole brain. And this is one of his most, urgent motivation for his activity. Now, I will talk to you about a model of the brain which was stimulated again by Lashley dilemma, however, let me show you, to a Japanese scientist, a Japanese physicist, Hiromi Umezawa. He is one of the father of modern quantum field theory, and he was in Naples in the middle of the 60s, and he went to study the brain as a physicist would study a piece of matter, a piece of condensed matter, because after all the brain is no more than matter. And he says, in any material in condensed matter physics, any particular information is carried by certain ordered pattern, maintained by certain long-range correlation mediated by massless quanta. Let me stop. As you see, he talks about condensed matter because he's a physicist of elementary particle physics and condensed matter physics. And he talks about information because there is the problem of memory. Neuroscientists, they tell us that there are synapses which change their state, there are connections between neurons, there are many special arrangements, but nevertheless still the problem exists of how some information is recorded and how we recall it. This is not solved the problem, not a solved problem. So his interest was especially in memory. And then he mentioned ordered patterns maintained by long-range correlation mediated by massless quanta. So, ordered patterns. Well, you are an ordered pattern because you sit in these chairs which have a specific order. We might change the order if you want. And this order arise because you have been coming to this conference and decided to listen to these talks. So, how this ordered pattern has been formed? If you want, let me put in this way. Which one is the probability for me among all inhabitants on the earth? How many? Maybe 7 billion. Which one is the probability that myself and that gentleman in the last row, we fall down in the same room for 3 days? Near zero. But it's not so because we are here. So this is a realized probability of with positive result. The point is that there exists a long-range correlation between me and that gentleman down there. This long-range correlation is our common interest in understanding consciousness, cognition, culture, physics, and so on. So this long-range correlation makes the miracle to pick up 2 people among 7 billion of people, 2 people, and bring them in the same room. So this is how a crystal is formed. Which one is the probability among billions of atoms in a crystal to sit in their crystalline site. 0, unless you work out a theory, a model, something you can check in the laboratory, which explain why two atoms very far away, among many, many of them, they sit to form the same crystal. You see, we talk of something which is almost a miracle, but it is he was saying, he was giving, massless quanta. Massless quanta. In quantum mechanics, you should know now, but also in quantum field theory, to each wave you can associate a quantum. So the electromagnetic radiation, the light, the quantum associated to it is the photon. If you have a crystals are classified by rigidity, or if you want elasticity, the reverse. So you have elastic waves, and in a crystal, the quantum of the elastic waves is called phonon. And the phonon is such massless quanta which span the whole system and keeps the atoms in their seats, in their sites. It looked to me, say Umezawa, that this is the only way to memorize some information. Memory is a printed pattern of order supported by long-range correlations. So this is the recipe he proposed to neuroscience to, the view to study neuron and glial cell and water in the brain in order to find if is there any pattern, any ordered pattern which could describe memory. In this proposal, in the papers he was producing with other collaborators, they were saying that in a first approximation we produce our model by considering the brain as a closed system. The brain is not a closed system, of course. You cannot close it. You will kill the person. The brain is open on its environment. It is always permanently open. But they were saying, let's, in a first approximation, consider the brain as a closed system. Now, it happened to me to extend their model on their indication to such kind of open situation. So the brain is an open system, and as we say, it is a dissipative system, namely a system which exchange with the environment any sort of energy, information, matter, and so on. So when you extend to Umezawa model to the dissipation regime, you get what I call the dissipative quantum model of brain. Please notice, the model is quantum, not the brain. This is different from some other model of the brain in which people consider neurons as quantum objects, but neurons are classical objects. So in this sense, this model is completely different from those models. Among those, there is one by Ameroff and Perros, for example, and so on. But this model is different, and it is different also because in that models it is used quantum mechanics. Quantum field theory, here the word field came. Quantum is dramatically different. When Dirac wrote this equation in the attempt to extend to relativity, the Schrödinger equation, there was a big surprise. The Schrödinger equation is an equation for one single particle. Dirac equation is an equation for a field, for infinitely many particles. So it describes not one single electron, but a field of electrons, which is completely different matter. So in this sense, I'm using quantum field theory, namely, we have a system with infinitely many degrees of freedom. And there is the point where the number of particles, if it is large, makes a big difference. So, I already told you about this energy means Nambu, Goldstone, who were the two physicists studying these long-range correlations. And examples I told you already are phonons, magnons in a ferromagnets, Cooper phase in superconductivity, and so on. Now, in the brain we have that above 90% of molecules are water molecules. Water molecule is quite light. In weight, water is about 80%. But if you count the molecules, since water molecules are light, the number of molecules is almost 90%. So a physicist absolutely cannot miss to consider the role of water in studying the brain. Why? Also because, not only because the number is so large, but also because a water molecule to a physicist is an electrical dipole. It's like a needle with a positive charge on one end and a negative one on the other end. Like a magnetic needle, but that is magnetic. You have also electrical dipoles. So when you have oscillation of dipoles, you get electromagnetic radiation. This is why your mobile works, because we are in a bath of electromagnetic radiation, and if there is a match between the frequency in this bath and the the frequency of your dipole in your mobile, then your dipole ring. So is something which cannot be missed. So in this model, the quantum variable are the electrical dipole vibrational field of the water molecules and of the other biomolecules, because all biomolecules possess an electrical dipole. At this point, we talk of spontaneous breakdown of rotational symmetry of the electrical dipole vibrational field. What means that if you have many arrows and there is no specified direction, you have a spherical symmetry. You can go in any direction is equivalent to another one. But if you try to polarize, as in the experiments of Professor Gauss, if you try to polarize, you might get in-phase oscillations of this dipole. You might get a resonance regime for such dipoles. So when you do something like that, you say that you break the rotational symmetry. You see, the word symmetry is beautiful. Symmetry are beautiful aesthetically and in many respects, but they do not have informational content. If you have many streets and you are in the middle, you do not know where to go if you want to go to, let's say, Delhi, then what you have to do, you have to break the symmetry. You have to put an arrow in which is written Delhi is that direction. That arrow breaks the symmetry and introduces an information. So breakdown of symmetry means creation of an order. Order is lack of symmetry. This is a little bit different from everyday life use of word order. Order usually is meant to be uniformity. It's not. That is a symmetry. So order is possibility to make distinctions, distinguishing one road from another one, one direction from another one. So if we have a spontaneous breakdown of symmetry, then a theorem which has been proved in laboratory tells you that a long-range correlation occurs. When we received the announcement of such conference, there was a breakdown of symmetry, because before there was nothing. At that point we were polarized, and we decided to come in this room for 3 days and to create such an ordered pattern, to share through this long-range interaction our interest in listening, discussing about these things. So in this way we create this long-range wave which we call dipole wave quanta, and these are Nambu-Gold's modes. As I told you already, neurons, glia cell and other physiological units are not quantum objects, they are classical objects. Now, the brain is an open system. We do not have mathematics to describe open systems. what we call the canonical theory, the canonical theory only describes closed systems. We do not know how to describe an open system unless we close it, unless we consider the other part outside the system or also inside the system, but in such a way all of it can be considered a closed system. Only at that point we can work out our mathematics. This is because we do not know much. As a matter of fact, we know nothing. But in any case, we try to do something. So, we have to close the system. Now, the system is our brain. Our brain is embedded in the environment. So we have to consider also the environment. To do that, we might decide to study all tiny mechanisms, all tiny interactions of our brain with the environment. How much air I'm perspiring, which is the strength I have to put in my voice to let you know what I'm saying. But all of this is not important if you want to study. The only important thing is that you have to balance the flux between your system and its environment. So from such a point of view, in a very first rough approximation, the environment becomes the place where the energy, let's say the energy, but is not only the energy coming from the system goes. So if you put yourself from the point of view of the environment, in the environment you receive is out for the brain, and vice versa. In for the brain is out for the environment. Now, how do you depict this fact if you work out a formula? Well, you just put a minus in front of the time in the formula when you describe the environment. This is like going on a freeway. You go in one direction, there are other people going in the other direction, and you say that they are going backwards, and you mean in space, because if you came from Delhi, the other one is going to Delhi. But you could also say that they go backward in time. This is exact from the point of view of mathematics and even of physics, even if it looks so strange, because the speed is given by the ratio between space and time. To get people going the opposite way to when you go, either you change space and then you say they go back to Delhi, or you change time and you say they go backwards. When you study the brain and its environment, the environment appears as the time reversed, because we change the sign of time, the time reversed the copy of the brain. So mathematically, you do that by doubling the degrees of freedom. You start with the brain, suppose this denotes some important degrees of freedom of your system, and then you go to a doubled couple, the old one you have, but also another one which I put tilde here, to mean the environment. So now you have to work with this doubled system. The important point is that you have to balance the energy. The energy getting out from the system minus the energy getting in the system, this difference must be zero. Of course, this is a balance in a perfect ideal situation. Is not zero in general, but what we try every day, every time, is to find an harmony with our environment. Since we do not exchange only energy, we exchange also information, values, and the environment tries to change us, and we try to change the environment. The word environment is too cool. Let me say the world. So the world tries to change us, we try to change the world. And in such a dialogue, continuous dialogue, always with some imbalance, in such a dialogue, perhaps there is the act of consciousness. Please don't kill me, but in this view, the consciousness is not something which belongs to me, my consciousness only, does not belongs only to me. My consciousness includes all of you, because I'm talking to you, and I belong to your consciousness. So consciousness, in this point of view, is relational, is in such a dialogue between me and my double. The double is this guy here, is the world. The world is my double. Of course, my double is the world as I see him, and each of us see the world in a different way. So each of us has a double. So if we are, I don't know, 180, I don't know how many people we are in this room, actually we are the double. We are 160 if we are 80. Because each of us has its own double to whom is talking every day, every moment, also in this moment. This will bring us to some extension of what I'm saying, but now let me go on this way. Here you find something which I already told you. A tilde denotes the mirror modes, and they account also for all the fluctuations. In the model, these are also quantum fluctuations, but normally in everyday life, this fluctuation corresponds to classical fluctuations. And here we should fill a gap. How do we go from a quantum model, from a quantum description, to a macroscopic description? At this point, you see, we have a measure of the ordering created by the breakdown of symmetry, and this is called order parameter. Here I call it n, and this n is a measure of the coherence of these massless quanta which are condensed. In this room, there is a condensation of a long-range correlation between me and each one of you, which has brought here, and between you and other ones of you. So we have a condensed state. A condensed state, which is an ordered state, and is a coherent state. Coherence means that we are in phase, like an orchestra. To be in phase, it means that we share the same thing, the same thinking, the same thought, the same feelings, as it happens when someone shares the same feelings. So coherence is the basis of this model. And this is a mathematics. Please notice, to me, it's not easy to translate in words what I can tell you much more easily in formulas. But what I tell you is very much near to the formula of the model. I want to say, I do not stretch the point. Because when you describe in words a formula, sometimes you say something which is not in the formula. But here what I'm telling you is just in the model, in the formula. So memory is not affected by quantum fluctuation because of coherence. You can show that by studying the coherent state. The coherent state is the quantum state which is nearest to classical state. And so you have a transition from a quantum state to a macroscopic quantum state. From such a point of view, for example, a crystal, a magnet, they are not classical objects. Although you cut a crystal, you sell, you buy, you give as a gift. However, that one is a macroscopic quantum state, because you cannot describe that crystal without going to the basic quantum dynamics of atoms and phonons. You see, these phonons, in the case of a crystal, are something quite interesting. Are particles, first of all, you can observe them. But if you break up the crystal, if you put salt, which is a crystal, in water, the crystal disassembly. You do not find any more the salt crystal. But you find the atoms of sodium and chlorine, but you do not find the phonons. The phonons exist as far as the crystal exists. So you have an identification of a structure, because they are particles, and the function. So in quantum field theory, a lot of antinomy, they disappear. We have we consider the brain as a macroscopic quantum state, made by macroscopic quantum state, or the brain as a macroscopic quantum system. But please notice macroscopic, not just quantum. This is an important point. And so we have a change of scale. We fill the gap, going from microscopic to macroscopic, because of coherence. You see, this gap is the same gap exactly of a biochemist. In biology, it's not clear how you can go from a biochemical reactions to behavior of the whole biological system. This is not clear. And this is one of the main problems in biology. So we have dissipation, most important thing. You cannot forget about dissipation. Then you have the time evolution of the state of describing the state of the brain at some volume, finite volume, and this is controlled, of course, by entropy, as it happens in this case of thermodynamic-like situations. So you have irreversibility of time evolution. You have, namely, breakdown of time reversal symmetry. You cannot reverse the arrow of time. This is why we get old. We cannot get young. We go only in one direction. The reason of this is dissipation, and we express it. Since in principle we could go both ways, backward in time and forward in time, in any physical system, in principle. But in practice, when you have a large number of particles, you go just in one direction, and this is due to statistical reasons. Here, the reason is dissipation. It's the fact that the system is open to the world. So you get the arrow of time, which is a privileged direction in time evolution. Now it is very, very interesting that the arrow of time for people like us is the same arrow of time of thermodynamics, and is the same arrow of time of cosmology. We are going all in the same time direction, and we cannot reverse time. But we have an image of a time reversed of ourselves. It is our double. Because if you remember, the double is the mirror in time image of ourselves. Mirror in time because it gets what we give, and vice versa, we have what it gives to us. Sorry. On this kind of time and time reversal and time breakdown of time reversal, great contribution have been given by George Sudarshan, who is one of my gut in physics, and I'm glad to present this picture here. Now, if you do some experiment, as Freeman has done and other ones do, to the same stimulus, you do not observe the same amplitude modulated of assembly of coherently oscillating neurons. If you take an NMR image of the brain, you see all those blobs. Those blobs are assemblies of coherently oscillating neurons. So if you give the same stimulus to a subject in different moments, you never find the same distribution of blobs in the brain. This is very important to a physicist because it means that the brain is autonomous in its own dynamics. This is crucial. So the brain receives inputs from the world, but then operates by itself. And this also means that in the brain you cannot say that there are representation of that stimulus, because the same stimulus gives always different excitations. So this is a crucial point. So, already, okay, I will jump a lot of things. So, what does the brain? The brain constructs meanings. Since it does not reproduce stimulus, it constructs meanings. And memory, we are quite certain with Walter Freeman, I collaborate with him, we are quite certain that the brain does not store information. Memory is not memory of information. Memory is memory of meanings. This is a crucial point, which I would like to stress. We do not remember how tall is that guy which we met yesterday. We remember what was our relation with him. What was the meaning attached with that guy. This is the crucial point. And then let me jump. Of course, since the interaction is always continuous and the balance is always unbalanced between me and my double, there is a continuous updating of a meaning. And every time I have a new perceptive experience, all my previous experiential activity is fully reordered, is fully rearranged. It's not like when you add one more item to a list in a dictionary. Every time we have a new perception, the whole panorama of previous perceptions is rearranged. So this is why we sometimes say, oh, now I understand. I change my point of view. How this is possible? If something would be wired in the brain, I cannot change. This is another point which comes from this model. So I told you already this, I skip. And in this way, by continuous updating of meaning, knowledge is constructed. And a vision of the world is formed for each of us. And intentionality may exercise in the action-perception cycle, which is so near to all phenomenology of Middle European phenomenology of Merleau-Ponty and other people which have been also mentioned during this conference. In the case we find such beautiful balance with our double, then that one is the aesthetical experience. Aesthetical experience is not necessarily artistic experience. Aesthetical experience means to be in harmony with our double. So that is the main characteristic of our brain. The dimension of our brain is pursuing the aesthetic experience, to find, to be in harmony with our double. And our double is continuously changing, it tries to change us, and we try to change him. So there is a continuous dialogue, and this dialogue, as I told you, perhaps is where consciousness appears. But so, for example, the dimension of such an aesthetic experience is surprise, astonishment. We are alive as far as we are able to be surprised. And here I like to remember some words from La Nausea of Sartre. And suddenly, all at once, the veil is torn away. I have understood. I have seen. This is the dimension of our everyday life. Where we meet with our double, forward in time, backward in time, we meet on the surface of this screen. The surface of this screen is the present, is the now. This is why consciousness is only present. Consciousness has no past, neither future, even though sum up all of our life before that act of experience. Consciousness is always in the present, is on this mirror, of time mirror. And this aesthetical experience, which also means that we judge beautiful something which is for us beautiful, is no matter of discussion, because it's our aesthetical experience, and for that reason is also aversive, because give us always a new standpoint, a new way to look at the world, a new vision of the world, so change what it was consolidated before. But okay, but we cannot mirror the world. We need something more. We need imagination. Just 2 more minutes, I'm sorry. So we need to mimesis in the sense of Aristotle. And this is possible because in this model we have the possibility to have mistakes. This is a privilege. We are not machine. We have the possibility to change our mind just because astonishment is our dimension. And from such point of view, to think, which usually, the act of thinking, let's say, usually is a rational activity, is said that is a rational activity, in this model appears more as activity coming from error, from making mistakes and from going around searching what can be useful to find for us the best of our aesthetic experience. But I have to be quick. I finished. Only one thing. There is at some point, I say that there are maybe 108 double and person in this room. We have to fit all together. So the brain is intrinsically, as intrinsic in it a social dimension. Because our double, they talk amongst themselves and we talk with those double. So also science is a convenience. We do not go on a boat if the boat is singing. So it's not convenient to use a boat which is singing. This is science. Science tells us what to do if it works. But we are always ready to change our minds, to make a new model, a new theory, if that theory at some point does not work. So all of it is a social, and social means also ethical, moral, and so commitment. But let me skip all of it. I told you coherence. Now it happens that nature loves fractals. Fractal, you can show, are macroscopic quantum systems. Here I could say something more, but my childman will kill me. So I just give you such a hint. Fractals, as you observe in nature in many occasions, are macroscopic quantum systems. Their basis is a quantum dynamics, which is a coherent dynamics. So from what I'm saying, it emerges that we have an integrated vision of nature on the basis of coherence. And in biology, especially in biology, people like to talk about codes. DNA is the genetic code. But coherence comes before codes. Nature is not a hierarchy of codes. Nature is a coherent, lives on the basis of a coherent dynamics. I'm sorry I cannot be longer on this point, but maybe we could read together this word by Darwin, which are famous words. In this view of life, with its several powers, having them originally breathed into a few form or into one, from so simple a beginning, endless form, most beautiful and most wonderful have been and are being evolved. The basis of this, from the point of view of a physicist used to quantum field theory, is the coherent dynamics. I have pictures which do not belong to time, it's just picture. Fractals. Just because oh, by the way, this is the brain. That one is brain. This is one of the experiments everybody can do. Spirals, they were at the beginning of our talk. Fractals everywhere. And beautiful picture, you see, this created both one logarithmic spiral and its double, because conservation, balancing of energy is crucial, and also the galaxy, this one is ours. So, thank you.